Welcome to where time falls quiet.
Babylon's Tablet That Beat. Pythagoras by 1,000 years. Take a moment to subscribe, so this place of calm is always here for you. What if everything you were taught about the beginning was actually the ending? What if the first civilization wasn't the first at all, but rather the remnant, the echo, the desperate reconstruction of something far older that had already been erased? Hold that thought for a moment, because the evidence doesn't whisper anymore. It screams through the silence of 10,000 years, carved into clay, buried in sediment, and encoded in the collective memory of cultures that should never have been able to speak the same language of catastrophe. There is a story that refuses to die. It appears in Mesopotamia, carved into cuneiform tablets still warm with the memory of the scribe's palm. It surfaces in the highlands of Armenia, in the valleys of China, among the Hopi of North America, in the sacred texts of India, and in the oral traditions of Australian Aboriginal peoples who have inhabited their land for over 60,000 years. The story is always the same, stripped of cultural decoration. The world was different once. The waters came. Nearly everything ended. A handful survived to restart what had been lost. For generations, scholars dismissed these narratives as mythology, as the universal human need to explain natural disasters through divine punishment or cosmic reset. But mythology doesn't leave a stratigraphic signature. Mythology doesn't deposit a uniform layer of silt across an entire region at precisely the same chronological horizon. Mythology doesn't explain why excavations in ancient Sumerian cities reveal a sudden, unmistakable interruption in the archaeological record. A sterile layer of clay, sometimes 8 feet thick, sandwiched between two distinct phases of human occupation. In 1929, British archaeologist Leonard Woolley was excavating the ancient city of Ur, one of the cradles of Sumerian civilization. His workers dug through the expected layers of pottery shards, broken tablets, and ash from cooking fires. Then they hit a layer of clean, water-deposited clay with no artifacts, no evidence of human presence whatsoever. Woolley ordered them to keep digging. Beneath that sterile flood layer, they found another city, older and equally sophisticated, with its own pottery styles, its own architectural conventions, its own written records. The flood wasn't a convenient mythological device, it was a stratigraphic fact. But here's where the silence begins to hum with implication. The flood layer isn't unique to Ur. It appears in the excavations of Uruk, Kish, Shuruppak, and Lagash. Each site reveals the same pattern: advanced urban centers, sudden inundation, a period of abandonment, then resumption of civilization at a slightly reduced level of sophistication. The clay remembers what the texts describe, and the texts, when read carefully, don't describe the birth of civilization. They describe its restoration. The Sumerian King List is one of the most unsettling documents ever recovered from the ancient world. It's not a mythological epic or a religious hymn. It's a bureaucratic inventory, written in the same clinical style used for temple grain storage and livestock counts. The document lists the kings who ruled before the flood and the kings who ruled after. The text marks a clear dividing line with a single, devastating sentence. Then the flood swept over. After the flood had swept over, when kingship was lowered from heaven, kingship was in Kish. Read that again. Not when kingship began, but when kingship was lowered from heaven. The language suggests restoration, not foundation. The document doesn't describe the origin of human government. It describes its resumption, And before that resumption, the list records rulers whose reigns span impossibly long periods. 43,200 years, 36,000 years, 28,800 years. Modern scholars dismiss these figures as symbolic or corrupted. But what if they weren't meant to be read as individual reigns at all? The Sumerian mathematical system was sexagesimal, base 60, the same system we still use to measure time and angles. Their astronomers tracked celestial cycles with precision that wouldn't be matched again until the invention of the telescope. The number 3,600 appears repeatedly in their texts as a sacred constant, the Sar, representing a full precessional cycle or a significant astronomical period. When you examine those impossibly long reigns through the lens of astronomical calculation rather than human biography, they stop being absurd. They become coordinates. They become a calendar. But a calendar measuring what? Precession, the slow wobble of Earth's axis that causes the position of the stars to shift over millennia, completes one full cycle every 25,920 years. The reigns listed before the flood, when divided by 3,600 or its multiples, align with significant markers in the precessional cycle. The texts weren't recording individual human lifespans. They were encoding astronomical time, preserving a chronology that spanned epochs, not generations. History wasn't struggling to record myth. It was struggling to preserve something it inherited but could no longer fully explain. And then there's the question of the flood itself. How could cultures separated by oceans and millennia describe the same catastrophic pattern with such consistent detail? The waters rose suddenly and covered the mountains. A chosen few were warned. They built vessels according to specific dimensions. They preserved breeding pairs of animals and seeds of plants. They survived to repopulate a devastated world. This isn't cultural diffusion where stories spread through trade routes and migration. These cultures had no contact with each other when their flood myths were first recorded. The geological record offers an explanation that academic orthodoxy has spent decades trying to avoid. At the end of the last ice age, approximately 11,600 years ago, the planet experienced a period of rapid, catastrophic warming. Massive ice sheets covering North America and Europe melted within centuries, raising global sea levels by more than 400 feet. Coastal civilizations, if they existed, would have been obliterated. Islands became submerged. River valleys became inland seas. The geography of the entire world was rewritten in the span of a few human lifetimes. But the flood narratives don't describe slow, gradual inundation over centuries. They describe sudden, apocalyptic deluge within days or weeks. Recent geological studies have identified evidence of massive meltwater pulse events, where the failure of ice dams released volumes of water equivalent to the flow of all the world's rivers combined, multiplied by a factor of 100, sustained for weeks. These pulse events coincide with extinction horizons in the fossil record, and with the sudden appearance of impact proxies, nanodiamonds and magnetic spherules, suggesting possible cosmic triggers for the rapid deglaciation. Imagine you are a survivor of such an event. Your city, your culture, your entire understanding of the world has been swept away. The libraries are gone, the temples are submerged, the specialists who maintain the astronomical observatories, the engineers who designed the irrigation systems, the scribes who recorded the mathematical tables, most of them are dead. You and a handful of others wash up on high ground with nothing but memory, and the desperate need to preserve what can still be saved. You won't have papyrus or clay tablets immediately. You'll have oral tradition, You'll have stories passed from parent to child in the dark, when the work of survival finally pauses long enough to remember what was lost. This is how knowledge becomes myth, not through ignorance but through trauma, not through primitive imagination, but through the desperate compression of technical information into narrative form that can survive without writing, without cities, without the infrastructure of civilization. The flood myths aren't religious parables. They're disaster protocols encoded in story because story was all that remained. The clay layers excavated in Mesopotamia, the genetic bottlenecks appearing in human and animal populations around 11,000 years ago, the sudden rise in sea levels, the mass extinction of megafauna, the appearance of impact proxies in sediment cores, and the universal flood narratives don't exist in isolation. They converge, they corroborate, they point to a single, unavoidable conclusion. Something ended. And what came after? What we call the birth of civilization in Sumer and Egypt and the Indus Valley around 5,000 years ago, wasn't humanity's first attempt at complex society. It was humanity's second attempt, built by people who still carried the memory of the first, who still preserved fragments of its knowledge, and who desperately tried to prevent the same loss from happening again. The silence you hear when you stand in the ruins of Uruk or walk through the British Museum past the Sumerian galleries isn't the silence of absence. It's the silence of something waiting to be heard, waiting for us to stop dismissing the evidence as coincidence and start reading it as testimony. The past whispers through the present in the dimensions of ancient structures that align with celestial coordinates we've only recently rediscovered, in mathematical tablets that contain knowledge their creators claimed they inherited, not invented, and in the shared memory of catastrophe that spans every continent and every culture. If the knowledge could be lost so completely once, what makes us believe we're immune to the same erasure? Every flood, whether of water, fire, or time, resets the world. And every reset forces the survivors to ask the same question we're asking now. What came before? What did they know that we've forgotten? And if we listen carefully to the clay, to the stone, to the carefully preserved but poorly understood myths, can we prevent the next silence from becoming permanent? Imagine holding a clay tablet no larger than your hand, its surface covered in wedge-shaped impressions pressed into the soft clay 4,000 years ago. The document is bureaucratic, almost mundane in its presentation. It lists names, cities, and numbers with the same dispassionate precision used for grain inventories and tax records. But the numbers themselves are impossible. The reigns it records span tens of thousands of years, an absurdity that has caused scholars to dismiss the entire document as mythological fantasy. Yet what if the impossibility isn't in the document, but in our reading of it? The Sumerian King List exists in multiple copies, inscribed across different periods and cities, yet the core information remains remarkably consistent. The most complete version, catalogued as the Weld Blundell Prism, stands in the Ashmolean Museum at Oxford, a small clay object that contains one of history's most disturbing chronologies. It begins with a statement of divine authority. After kingship descended from heaven, the kingship was in Eridu. Not established, not invented, but descended. The language suggests transfer, not origin. It implies that kingship, the concept of organized human government, came from somewhere else, was given rather than developed. The list then proceeds to name 8 kings who ruled before the Great Flood, their reigns measured in a unit called the Sar, equivalent to 3,600 years. Alulim of Eridu ruled for 8 Sar, totaling 28,800 years. Al-Aljar ruled for 10 Sar, 36,000 years. Enmenluana ruled for 12 Sar, 43,200 years. The total duration of pre-flood kingship, according to the tablet, spans 241,200 years. To the modern reader, these numbers are preposterous, clear evidence that the document mixes history with mythology in a way that renders it useless as a historical source. But the Sumerians were not primitive. They were the inheritors and perhaps the inventors of the most sophisticated mathematical system the ancient world had ever known. Their sexagesimal system, base 60, still governs how we measure time and angles today. They calculated square roots and cube roots. They understood geometric progressions. They tracked the movements of Venus with such precision that their observations align with modern astronomical data to within fractions of a degree. These were not people prone to mathematical carelessness or symbolic hyperbole in their official records. So why would they inscribe impossibly long reigns into what appears to be a formal state document? The answer lies in recognizing that the King List isn't recording individual human lifespans. It's encoding astronomical time. The Sar, that fundamental unit of 3,600 years, isn't arbitrary. It appears throughout Mesopotamian mathematics as a sacred constant, a number that divides evenly into the major celestial cycles known to ancient astronomers. The precession of the equinoxes, the slow wobble of Earth's axis that causes the apparent position of the stars to shift over millennia, completes one full cycle in approximately 25,920 years. When you divide this by the Sar, you get 7.2 cycles, a number that appears repeatedly in Sumerian mathematical tablets as a key ratio. Moreover, the individual reign lengths aren't random. They're multiples of 3,600 or its significant fractions. Alolim's 28,800 years equals 8 Sar. Alaljar's 36,000 years equals 10 Sar. The numbers are clean, deliberate, chosen for their mathematical relationships to one another. When plotted against the precessional cycle, these reign lengths mark significant astronomical epochs, moments when specific constellations would have risen at the vernal equinox, when the sky itself would have appeared fundamentally different from Earth's perspective. The King List isn't mythology struggling to be history. It's astronomy struggling to be preserved in the only format that survived the flood: narrative. But here's where it becomes deeply unsettling. If the pre-flood section encodes astronomical time, then it's recording observations that span not generations, but geological epochs. To accurately track precessional movement requires continuous observation over thousands of years, a sustained scientific program maintained across countless human lifetimes. This isn't primitive sky watching. This is institutional astronomy, the kind that requires permanent observatories, trained specialists, written records that accumulate over centuries, and a stable civilization sophisticated enough to prioritize pure research over immediate survival needs. The post-flood section of the King List presents a different pattern entirely. After the flood, the reign lengths drop dramatically. They're still long by modern standards, hundreds of years rather than tens of thousands, but they're within the realm of possibility if we account for either dynastic succession being conflated with individual rulers or the use of different timekeeping systems. The shift is stark and deliberate. Before the flood, astronomical epochs. After the flood, something approaching human chronology. The document itself marks the transition from one type of timekeeping to another, from a civilization capable of tracking cosmic cycles to one struggling to maintain basic continuity. Consider what this implies. The people who compiled the King List after the flood had access to pre-flood records or traditions that preserved astronomical data. They knew that their predecessors had tracked time on a scale that they themselves could no longer maintain. They knew that kingship had existed before, that civilization had functioned at a level of sophistication that the post-flood world was still struggling to recover. And they knew that the flood had represented not just a break in political continuity, but a catastrophic loss of knowledge, a severance from a past that had measured time in epochs rather than reigns. This pattern of encoded knowledge appears elsewhere in Mesopotamian texts. The Babylonian astronomical diaries, clay tablets that record nightly observations of celestial bodies, contain data that presupposes centuries of prior observation. The Venus tablet of Amisaduqa tracks the synodic cycle of Venus, the period between its appearances as morning and evening star, with precision that requires understanding of orbital mechanics. The tablet presents this knowledge as traditional, inherited wisdom from the antediluvian period. Similarly, the Muld Apin tablets, astronomical compendiums from the 7th century before the Common Era, contain star catalogues and celestial coordinates that are accurate for dates thousands of years earlier than their inscription, suggesting they were copied from much older sources. The Greek historian Berossus, a Babylonian priest writing in the 3rd century before the Common Era, had access to temple archives that have since been lost. He reported that Babylonian astronomical records extended back for 473,000 years before the flood. Modern scholars dismiss this as Berossus exaggerating or misunderstanding his sources. But what if he wasn't? What if he was accurately reporting what the temple archives claimed, and those archives were preserving the same astronomical chronology encoded in the King List? There's a parallel worth examining. The ancient Egyptians maintained similar king lists that record extraordinarily long dynastic periods before the unification of Upper and Lower Egypt. The Turin Canon, a papyrus from the 13th century before the Common Era, lists not just human pharaohs but pre-dynastic rulers described as gods and spirits, whose reigns span thousands of years. The Palermo stone, even older, records similar information. Manetho, an Egyptian priest writing in the 3rd century before the Common Era, compiled a history that included dynasties of gods who ruled for tens of thousands of years before the first human pharaoh. The pattern repeats: sophisticated civilizations preserving traditions of impossibly ancient predecessors, whose timescales suggest astronomical rather than human chronology. What were these cultures trying to preserve? Not mythology, not religious fantasy, but a calendar, a way of marking time that extended far beyond individual human memory, that tracked cycles too long for any single generation to observe. The antediluvian kings weren't mythological figures. They were chronological markers, epoch names for periods defined by celestial configurations. The document preserves not who ruled, but when things happened, measured against the only clock that operates on geological timescales: the movement of the stars themselves. And this is where the terror quietly sets in. If these documents encode real astronomical observations spanning tens of thousands of years, then they record a civilization that existed long enough and was stable enough to conduct multi-generational scientific programs. They had the luxury of pure research. They built institutions that outlasted individual lifetimes. They developed notation systems capable of preserving numerical precision across centuries. And then the flood came, and all of that institutional memory, all of that accumulated knowledge, was compressed into narrative form and inscribed onto clay tablets by survivors who could no longer fully explain what they were preserving. The Sumerian King List doesn't describe the beginning of human government. It describes its resumption after catastrophic interruption. The text itself acknowledges this. After the flood had swept over, when kingship was lowered from heaven, kingship was in Kish. Not begun in Kish, not invented in Kish, not lowered, restored. The word choice is deliberate and consistent across all copies of the text. Kingship wasn't a Sumerian innovation. It was a Sumerian inheritance from a civilization that had measured time in epochs and tracked the stars with a precision that wouldn't be matched again for thousands of years. So when you encounter impossibly long reigns in ancient texts, pause before dismissing them as mythology. Ask instead, what were they measuring? What cycles were they tracking? What knowledge were they desperately trying to preserve in the only format that could survive the loss of everything else? The clay doesn't lie. It remembers. And what it remembers is a world that measured time differently because it existed long enough to watch the stars themselves change position. A world sophisticated enough to know that knowledge could be lost, and desperate enough to encode that knowledge in stone and clay before the waters rose and the silence began. In 1945, a small clay tablet catalogued as Plimpton 322 sat in the archives of Columbia University, largely ignored by scholars who assumed it was an administrative document, perhaps a merchant's accounting ledger or a student's practice exercise. The tablet measured roughly 5 inches by 3 inches, its surface covered in 4 columns of cuneiform numbers arranged in 15 rows. It had been purchased decades earlier from an antiquities dealer, its original archaeological context lost to the private market. But when mathematicians finally examined it closely, they realized they were looking at something that shouldn't exist. A table of Pythagorean triples computed with an algorithmic sophistication that wouldn't be rediscovered until the 20th century. A Pythagorean triple is a set of 3 whole numbers that satisfy the equation where the square of one number plus the square of another equals the square of the third. The simplest example is 3, 4, 5. 3 squared plus 4 squared equals 5 squared. These triples are foundational to geometry, trigonometry, and architectural engineering. They allow you to construct perfect right angles, calculate distances without direct measurement, and design structures that won't collapse under their own weight. The Greek mathematician Pythagoras, working around 500 years before the Common Era, is credited with discovering the theorem that bears his name. Except the Babylonians were using it more than 1,000 years before Pythagoras was born. Plimpton 322 doesn't just list a few simple Pythagorean triples. It contains 15 rows of increasingly complex triples, some involving numbers in the thousands, arranged in a pattern that suggests they were generated using a systematic algorithm rather than discovered through trial and error. The tablet also includes calculations of what modern mathematicians recognize as trigonometric functions, specifically the secant and tangent ratios, computed to a precision that implies understanding of mathematical principles that weren't supposed to exist for another 3 millennia. The numbers aren't approximations. They're exact. They're elegant. They demonstrate mastery. But here's what makes Plimpton 322 truly unsettling. It's not unique. It's one of hundreds of mathematical tablets recovered from ancient Mesopotamia. And the more we examine them, the clearer it becomes that Babylonian mathematics wasn't primitive or trial-based. It was algorithmic, systematic, and in some areas more sophisticated than what would be taught in European universities until the 16th century of the Common Era. Tablet YBC 7289 contains a calculation of the square root of 2 accurate to 6 decimal places, using a method identical to the modern iterative algorithm. Tablet IM 67118 solves cubic equations using techniques that wouldn't be published in Europe until the work of Cardano in the 1500s. The standard academic explanation is that the Babylonians developed these methods independently through centuries of incremental progress, that their mathematical sophistication was the natural result of administrative need combined with intellectual curiosity. But the archaeological record doesn't support gradual development. When Babylonian mathematics first appears in the textual record, around 2,000 years before the Common Era, it's already fully formed. There's no evidence of earlier, simpler versions. There's no trial and error period. The system emerges complete, with standardized notation, sophisticated problem-solving techniques, and a level of abstraction that suggests institutional training rather than individual innovation. Consider what it takes to develop a mathematical system of this sophistication. You need a stable society wealthy enough to support a class of specialists who don't produce food or goods, but instead manipulate abstract symbols. You need an educational infrastructure capable of transmitting complex knowledge across generations without degradation. You need institutional memory, archives of worked examples and reference tables that students can consult and master. You need writing not just for recording transactions, but for exploring hypothetical scenarios and preserving failed approaches so others don't repeat them. All of this requires centuries of peace and prosperity, a civilization secure enough to invest in pure research. But the Sumerian and Babylonian civilizations, as we understand them, were never that stable. They were constantly invaded, overthrown, rebuilt under new management. Cities were sacked, temples were burned, populations were displaced. The archaeological record shows repeated destruction layers, periods of abandonment, sudden shifts in material culture that indicate catastrophic political collapse. This isn't the environment where mathematical knowledge accumulates over centuries. This is the environment where it's desperately preserved in whatever form survives the next invasion. So where did it come from? The Babylonians themselves provide an answer if we're willing to listen. Their mathematical tablets frequently include phrases like, according to the old procedure, or as was done in ancient times. They describe their methods as inherited, not invented. The astronomical texts explicitly state that their observations and calculation methods were recovered from antediluvian sources, knowledge that survived the flood in fragmentary form and was being carefully reconstructed by scribes who knew they were working with incomplete information. Tablet CBS 10673 provides a particularly striking example. It's a mathematical problem text that asks the student to calculate the dimensions of a rectangle given its area and the length of its diagonal. The solution requires knowledge of the Pythagorean theorem, quadratic equations, and square root approximations. But the tablet frames this as a standard exercise, not an advanced problem. It's presented as basic competency, the kind of problem a student would work through before moving on to more complex material. This suggests that the Babylonian mathematical curriculum was teaching concepts as foundational that we consider advanced topics reserved for upper-level secondary education. More troubling still is the evidence of mathematical knowledge that the Babylonians clearly possessed, but couldn't fully explain. Their astronomical tablets predict lunar eclipses and planetary positions using calculation methods that presuppose understanding of elliptical orbits and gravitational perturbation. They shouldn't have this knowledge. The heliocentric model wasn't proposed in Western astronomy until Copernicus in the 1600s, and elliptical orbits weren't confirmed until Kepler in the early 1600s. Yet the Babylonian calculations work. They produce accurate predictions. The mathematics is correct even when the theoretical framework that would justify it won't be developed for 3,000 years. This is the signature of inherited knowledge, information preserved and used effectively, despite incomplete understanding of its foundations. It's what happens when catastrophe destroys the institutional framework that generated the knowledge but leaves behind the practical results. The Babylonian astronomers were using calculation methods that worked, that had been tested and verified over generations, but whose derivation had been lost. They were the custodians of a mathematical legacy they couldn't fully reconstruct. The same pattern appears in Babylonian geometry. They knew that the area of a circle was proportional to the square of its radius, and they used a value for the constant of proportionality, what we call pi, that was accurate to 2 decimal places. They calculated the volume of truncated pyramids and spherical segments. They solved problems involving compound interest and exponential growth. These aren't primitive achievements. These are the mathematical tools of an advanced civilization, one with complex trade networks, architectural ambitions, and administrative needs that required precise calculation. But the most unsettling aspect of Babylonian mathematics isn't its sophistication. It's the gaps. There are concepts they clearly understood in practice but never formulated as abstract principles. There are techniques they used consistently but never explained in their problem texts. It's as if they had a comprehensive reference manual but only fragments of the theoretical treatise that would explain why the methods worked. They had the algorithms but not the proofs. They had the results but not the derivations. This is exactly what you'd expect if their mathematical system was recovered from an earlier civilization that had developed the full theoretical framework, but that framework had been lost in a catastrophic event. The survivors would preserve the practical techniques, the tables and algorithms that had immediate utility, but the abstract theory, the elegant proofs and logical foundations would be harder to transmit without institutional support. Mathematics becomes cookbook recipes rather than interconnected theory. And here's the question that haunts every examination of these tablets. If the Babylonians were reconstructing knowledge from antediluvian sources, how sophisticated was the original system? What did the complete mathematical framework look like before the flood? The fragments that survive to be inscribed on clay tablets represent advanced material by any measure. What level of knowledge did the civilization possess that considered these concepts elementary? The clay tablets we've recovered represent what could be baked and preserved, what could be quickly inscribed and stored in temple archives before the next invasion, the next fire, the next flood. They're emergency backups, not comprehensive textbooks. They're the mathematical equivalent of seed banks, preserving essential information in compressed form against future catastrophe. And if this is what they considered worth preserving, what knowledge did they consider too basic to bother recording, assuming it would be obvious to any educated person? The mathematics that shouldn't exist does exist, inscribed in cuneiform on clay tablets that have survived 4,000 years of fire, flood, and human destruction. It exists complete and sophisticated, with no developmental precursor, no evidence of gradual discovery. It exists with the Babylonians' own acknowledgement that they inherited it from sources older than their civilization. And it exists as a warning that knowledge, once lost, may take millennia to rediscover, if it's ever rediscovered at all. The clay remembers what we've forgotten, that civilization's greatest achievements aren't always its own inventions, and that the line between innovation and restoration is far thinner than we'd like to believe. Stand before the Great Sphinx of Giza and you're confronted with one of archaeology's most carefully maintained contradictions. The monument crouches in its limestone enclosure, weathered and ancient, its leonine body stretching 73 meters in length, carved from a single outcrop of bedrock left behind when the surrounding stone was quarried for the pyramids. According to conventional Egyptology, it was built during the reign of Khafra, around 2,500 years before the Common Era, making it approximately 4,500 years old. But the stone itself tells a different story, one written in erosion patterns that speak of centuries of rainfall in a region that has been arid desert for the last 5,000 years. In 1990, Robert Schoch, a geologist from Boston University, was invited to examine the Sphinx from a purely geological perspective, setting aside the archaeological assumptions about its age. What he found was geologically unmistakable. The limestone body and the walls of the enclosure surrounding the Sphinx displayed deep, vertical erosion channels, rounded and undulating weathering patterns characteristic of water erosion rather than wind and sand abrasion. These weren't the sharp, horizontal striations you'd expect from 4 millennia of desert winds carrying abrasive sand particles. These were the smooth, wave-like fissures carved by sustained precipitation, by centuries of rainfall flowing over the surface and pooling at the base. Schoch's analysis was straightforward and devastating. The last period when the Giza Plateau experienced rainfall sufficient to produce this degree of erosion ended between 7,000 and 9,000 years before the Common Era, during the African humid period when the Sahara was grassland and the Nile Valley was lush with vegetation. For the Sphinx to display this weathering pattern, it would need to have been carved and exposed to the elements during that wet period, making it at minimum 9,000 to 11,000 years old, more than twice the age assigned by conventional archaeology. The stone doesn't interpret itself. It records what happened to it, and what happened to the Sphinx was centuries of rain. The immediate academic response was predictable and fierce. Egyptologists argued that Schoch was overstepping his expertise, that geological evidence couldn't override the historical and archaeological consensus. They pointed to the lack of any Egyptian texts or inscriptions dating the Sphinx earlier than the 4th dynasty. They noted that the architectural style matched other Old Kingdom monuments. They insisted that the weathering could be explained by other mechanisms: groundwater seepage, chemical weathering, or localized climatic variations that might have produced brief wet periods even within the generally arid epoch. But geology isn't a matter of interpretation or scholarly consensus. It's a record written in stone through processes that operate according to physical laws, regardless of human preference. When you compare the erosion on the Sphinx to erosion on other limestone structures at Giza that are definitively dated to the Old Kingdom period, the difference is stark. The temples and tombs carved during Khafra's reign show typical desert weathering: sharp edges, horizontal abrasion from wind-driven sand, the characteristic erosion pattern of an arid environment. The Sphinx shows something fundamentally different, a weathering signature that requires a different climate, a different era. Moreover, the differential erosion within the Sphinx enclosure itself provides additional evidence. The walls of the enclosure were quarried from the same limestone formation as the Sphinx body, yet they show even more pronounced water erosion because they've been exposed longer. The floor of the enclosure, which was cleared and re-exposed during later Egyptian dynasties, shows less erosion. The pattern is consistent with the original carving having occurred during the wet period, followed by centuries of rainfall erosion, then burial under wind-blown sand during the desertification, and finally re-excavation during the historical Egyptian period. The Sphinx isn't an Old Kingdom creation, it's an Old Kingdom restoration of something much older. This interpretation gains support from Egyptian texts themselves, if we read them carefully. The inventory, stela discovered in the 19th century near the Sphinx, describes Khufu, the pharaoh credited with building the Great Pyramid, ordering restoration work on the Sphinx after it had been damaged by lightning. The text explicitly states that Khufu found the Sphinx already ancient, already in need of repair. Conventional Egyptology dismisses the inventory stela as a later forgery, despite it being carved in stone using Old Kingdom hieroglyphic styles, because it contradicts the established chronology that places the Sphinx's construction during Khafra's reign, after Khufu's death. But what if the inventory stela is accurate? What if Khufu and Khafra didn't build the Sphinx but merely restored it, cleared it of sand, perhaps recarved the head which is noticeably out of proportion with the body? The erosion evidence supports this interpretation. The body shows deep weathering consistent with extreme age. The head, smaller and more refined, shows weathering more consistent with later Old Kingdom work. Geologically, this suggests the head was recarved from an earlier, more weathered version, possibly during the 4th Dynasty restorations that Egyptian texts describe but that modern scholars dismiss. The implications extend beyond the Sphinx itself. If the monument predates Egyptian civilization by thousands of years, then who carved it? The archaeological consensus holds that before the rise of dynastic Egypt around 3,100 years before the Common Era, the Nile Valley was inhabited only by scattered Neolithic communities, with no capacity for monumental architecture. The Sphinx, with its precise astronomical alignments and sophisticated understanding of quarrying and sculpture, would require a civilization with organizational capacity, technical knowledge, and cultural motivations we don't see in the Neolithic archaeological record. Unless we're not seeing the complete archaeological record. The Nile Valley has been continuously inhabited and modified for thousands of years. Monuments have been built over earlier monuments. Cities have been constructed atop cities. The annual flooding of the Nile, which deposited rich sediment that made Egyptian agriculture possible, also buried and destroyed earlier settlements. What we excavate and study represents whatever survived this continuous process of burial and rebuilding. We're sampling the archaeological record, not reading it complete. And there's another layer of evidence often overlooked: the Sphinx's astronomical alignment. The monument faces due east, positioned to observe the sunrise at the equinoxes. But due to precession, the slow wobble of Earth's axis, the constellation that rises at dawn on the spring equinox, changes over a cycle of approximately 26,000 years. During the 4th Dynasty, the constellation Taurus the Bull rose at the spring equinox. But go back to around 10,500 years before the Common Era, and the constellation Leo the Lion occupied that position. The Sphinx, a lion's body facing the eastern horizon, would have gazed at its celestial counterpart at sunrise during the age of Leo. Is this coincidence? Perhaps. But ancient astronomical alignments were never casual. They required sophisticated observation and calculation. They demonstrated the civilization's ability to track celestial cycles and encode that knowledge in permanent monuments. If the Sphinx was positioned to mark the age of Leo, then its construction dates to the very period that the geological evidence suggests: the terminal Pleistocene, the end of the last ice age, when the climate was wet, when the Sahara was green, and when, according to multiple catastrophe myths, the old world was ending. The scars on the Sphinx aren't just weathering patterns, they're a chronometer, a geological clock that measures time in rainfall and erosion rather than years and dynasties. They tell us that the monument stood exposed to the elements during a climate period that ended thousands of years before dynastic Egypt. They tell us that Egyptian civilization didn't invent monumental architecture, but inherited it, restored it, built new monuments in its shadow while knowing they were following in the footsteps of predecessors whose names had been lost to time. And here's the question that the weathered limestone poses. If the Sphinx is a remnant of pre-Egyptian civilization, what else did they build that hasn't survived? What knowledge did they possess that wasn't carved in stone? We only know about the Sphinx because it's massive enough to withstand 11,000 years of erosion, burial, and re-excavation. How many smaller monuments, how many settlements, how many libraries and workshops were lost completely, erased by the transition from wet Sahara to desert, by the catastrophic flooding that marked the end of the Ice Age? The rain that carved those distinctive erosion patterns into the Sphinx was the same rain that accompanied the collapse of the Old World, the final wet phase before desertification, the climatic shift that coincides with flood narratives across cultures. The Sphinx stood through that transition, witnessed the transformation from grassland to desert, from the old civilization to the new. Its weathered face doesn't just mark time, it marks the boundary between what was remembered and what was lost, between the world before the catastrophe and the world after, between the civilization that carved it and the civilization that found it already ancient. Every time you see images of the Sphinx, you're looking at evidence that contradicts the carefully constructed timeline of human civilization. You're seeing proof, written in stone and weathering, that organized, technically sophisticated cultures existed thousands of years before they were supposed to. And you're seeing the result of academia's choice to privilege archaeological consensus over geological evidence, to maintain comfortable narratives over uncomfortable facts. The stone doesn't lie. It remembers the rain, and the rain remembers the world before this one. The world that ended in flood and was buried under sand, waiting for someone willing to read what the scars have preserved. Imagine a library so vast that its catalogue alone required multiple clay tablets to record. Imagine shelves lined with thousands of texts covering astronomy, mathematics, medicine, engineering, history, and literature. Imagine scribes trained from childhood to copy, preserve, and transmit this accumulated knowledge across generations. Now imagine that library burning, flooding or simply crumbling into dust, leaving behind only fragments, only references in later texts that mention works no one can find anymore. Knowledge that was common enough to cite, but is now completely lost. This isn't hypothetical. We know such libraries existed because ancient texts constantly referenced them. The Babylonians spoke of antediluvian archives, repositories of knowledge from before the flood that survived in fragmentary form and were being painstakingly reconstructed by scribes who knew they were working with incomplete information. Egyptian texts mention the House of Life, temple libraries that contained not just religious rituals, but technical manuals, medical treatises, and astronomical observations accumulated over dynasties. The Greeks wrote about visiting libraries in Egypt that contained works of immense antiquity, books that described technologies and sciences their own civilization was still struggling to understand. The Library of Alexandria, often mourned as the greatest loss of ancient knowledge, was actually a late arrival to this tradition. When it was founded in the 3rd century before the Common Era, it was attempting to gather and preserve texts from older collections scattered across the Mediterranean and Near East. The librarians at Alexandria didn't consider themselves innovators, but archivists, collectors of knowledge that predated their own civilization. They sent agents across the known world to find and copy ancient texts, offering exorbitant sums for works of particular antiquity or rarity. What were they looking for? What knowledge did they know existed but couldn't access? Berossus, that Babylonian priest we encountered earlier, claimed he had access to temple archives extending back hundreds of thousands of years. Whether his chronology was literal or encoded in astronomical time, his testimony confirms that Babylonian temples maintained comprehensive archives that they considered fundamental to civilization itself. These weren't casual collections, they were institutions staffed by professional scribes, organized according to sophisticated cataloging systems. We know this because the fragments that survived show standardized formatting, cross-referencing between texts, and catalog numbers that imply much larger collections than what archaeology has recovered. One particularly haunting example is the astronomical text known as Mul Apin, a Babylonian star catalogue that lists constellations, their rising and setting times, and their relationships to seasonal festivals. The text itself dates to around 700 years before the Common Era, but the astronomical data it contains is accurate for a date roughly 2,000 years earlier. This means the Mul Apin is a copy of an earlier work, or more precisely, a compilation of earlier observations that had been preserved in archives for over a millennium. The scribes who compiled it note explicitly that they're working from ancient exemplars, copying knowledge they inherited rather than discovered. But here's what makes this unsettling. The mul.apin is incomplete. It references other texts, other catalogues that would explain certain calculations or provide additional star positions. It assumes the reader has access to supplementary materials that no longer exist. It's like finding a textbook that constantly tells you to see Chapter 7 or refer to Appendix C, except Chapter 7 and Appendix C are gone. You can tell from the structure that a larger work once existed, a more comprehensive archive of astronomical knowledge, but all that survives is this single fragment. The same pattern appears in medical texts. The Egyptian Edwin Smith papyrus, dating to around 1600 years before the Common Era, is a surgical manual that describes 48 different medical cases, from skull fractures to spinal injuries, with diagnostic procedures and treatment protocols that demonstrate sophisticated understanding of anatomy and physiology. The text is clinical, systematic, organized like a modern medical reference. But it ends abruptly mid-sentence, and a note in the margin indicates this is a partial copy of a longer work. Where's the rest? What other medical knowledge did the complete text contain? Even more disturbing are the Egyptian medical texts that reference specific plants and compounds by names that no longer appear anywhere else in the historical record. They prescribe treatments using materials whose identity has been lost. The recipes exist, but the ingredients are mysteries. This suggests that the medical knowledge was being copied from sources that predated the loss of botanical terminology, that there was once a comprehensive pharmacological tradition with its own technical vocabulary, and that vocabulary disappeared when the libraries that defined it were destroyed. Mathematical texts show the same fragmentary quality. The Rhind mathematical papyrus, another Egyptian text from around 1600 years before the Common Era, contains 84 mathematical problems with solutions. But many problems include phrases like, according to the old reckoning, or as calculated in ancient times, indicating the scribe was copying methods he inherited. Some solutions use techniques the scribe clearly doesn't understand, procedures that work but whose derivation has been lost. He's preserving the algorithm but not the proof, maintaining the practical knowledge while the theoretical foundation crumbles. The Library of Ashurbanipal at Nineveh, excavated in the 19th century, provides our most direct glimpse of what these ancient archives actually contained. The excavation recovered over 30,000 clay tablets covering every aspect of Mesopotamian knowledge: omens, astronomy, medicine, mathematics, literature, history, law, and magic. The collection is staggering in its scope and sophistication, but the tablets themselves repeatedly note they are copies of older works, many from antediluvian sources. The librarians were explicit about this. They were preserving knowledge from before the catastrophe, knowledge they considered more authoritative and accurate than their own contemporary understanding. One tablet in particular stands as testimony to this archival tradition. It's a catalogue, a list of texts in the library's collection, organized by subject and including the opening line of each work for identification purposes. The catalogue lists hundreds of texts. But when archaeologists compared the catalogue against the recovered tablets, they found that less than half of the listed works survived in the archaeological record. The majority had been lost, destroyed when the library burned during the sack of Nineveh in 612 before the Common Era. We have the catalogue entries, the titles and first lines, but not the texts themselves. We know they existed, we know what subjects they covered, but we can't read them. They're gone. This is the recurring nightmare of ancient archives. We know far more knowledge once existed than what has survived. Every catalogue, every cross-reference, every citation of a lost work is evidence of a vast body of literature and technical knowledge that has been erased. And the truly haunting realization is that what we've lost may have been more sophisticated than what survived, because practical texts, the ones that get used and copied repeatedly, have a better chance of preservation than theoretical works, pure research, or comprehensive encyclopedias that were consulted rather than memorized. Consider what this means for our understanding of ancient civilizations. We judge their knowledge by what survived, but survival is a terrible filter. Clay tablets survive fire, papyrus doesn't. Stone inscriptions survive floods, wooden tablets don't. Practical manuals get copied because scribes need them. Theoretical treatises get referenced but not replicated. We're not seeing ancient knowledge complete. We're seeing what happened to be durable enough or useful enough to survive multiple catastrophes. We're reading the footnotes and trying to reconstruct the dissertation. The fragments that remain all point in the same direction, toward lost archives of comprehensive knowledge, toward civilizations that organized and preserved information on scales that required institutional support, professional scribes, and centuries of stability. The Babylonians didn't randomly write down mathematical problems. They copied them from collections. The Egyptians didn't spontaneously develop their medical and astronomical knowledge. They inherited it from temple archives that stretched back beyond recorded history. The Greeks didn't invent there. They translated and adapted texts they found in older libraries. And all of those older libraries, the comprehensive archives from before the catastrophes, are gone. Burned, flooded, buried, or simply allowed to decay when the institutions that maintain them collapsed. What survives are copies of copies, fragments that were preserved because someone thought they were important enough to inscribe in stone or fire in clay. Knowledge that was considered fundamental enough to warrant the expense and effort of preservation. Everything else, the bulk of ancient literature, has vanished so completely we only know it existed because of these haunting references to works we can no longer read. The library that burned before it was built isn't a single location. It's the collective intellectual achievement of pre-catastrophe civilizations, knowledge that was archived, organized, and maintained in repositories across the ancient world. repositories that were systematically destroyed by flood, fire, conquest, and time. What we call the birth of civilization in Sumer and Egypt was actually a recovery project, a desperate attempt to reconstruct what had been lost, to preserve in permanent form whatever fragments could be salvaged from the ruins. And the texts themselves, when they describe their sources as antediluvian, as recovered from before the flood, are telling us exactly that. We're not the first to try to preserve knowledge against catastrophe, but we might be the first to willfully ignore the evidence that civilizations before us failed at that same task. That knowledge once lost can remain lost for millennia, and that every reference to a lost text is a reminder that what we don't know about the ancient world vastly exceeds what we do. Languages don't appear from nowhere. They evolve slowly over centuries, borrowing from neighbors, simplifying complex sounds, developing new words for new concepts as culture and technology advance. We can trace the evolution of English back through Middle English to Old English to Proto-Germanic and, ultimately, to Proto-Indo-European, a reconstructed ancestor language spoken thousands of years ago. We can watch Spanish, French, and Italian diverge from Latin, see how each retained certain features while innovating others. Language evolution is messy, gradual, and always leaves traces of its ancestry, except when it doesn't. Sumerian, the language of the world's first recognized civilization, has no known relatives. It's a linguistic isolate, appearing fully formed in the written record around 3,200 years before the Common Era, with no apparent precursor, no simpler earlier version, no related languages from which it might have descended. When scholars first deciphered cuneiform in the 19th century, they expected to find Sumerian connected to other language families in the region. But it shares no meaningful vocabulary with Semitic languages like Akkadian, Babylonian, or Hebrew. It has no structural similarities to Indo-European languages. It doesn't relate to the Dravidian languages of India or the Sino-Tibetan languages of East Asia. Sumerian stands alone, linguistically unprecedented and unexplained. But the isolation isn't just a matter of vocabulary or grammar. It's the sophistication that's unsettling. When Sumerian first appears in written form, it's already a mature language with complex grammar, extensive vocabulary, and specialized technical terminology. There's no developmental phase where the writing is clumsy or the vocabulary limited. The earliest texts are administrative documents recording temple offerings and trade transactions, but they use language as sophisticated as any later literary work. The grammar is fully developed with 8 noun cases, verb aspects that distinguish perfective from imperfective action, and a system of postpositions that functions like prepositions in English. This isn't a language taking its first steps into literacy. This is a language that's been spoken and refined for generations before anyone thought to write it down. The real mystery emerges when you examine Sumerian technical vocabulary. The language contains hundreds of words for specialized tools, architectural elements, astronomical phenomena, and mathematical concepts. These aren't simple descriptive terms formed by combining common words. They're distinct lexical items, unique vocabulary that suggests long-standing technical traditions. There are separate words for different types of temple structures, for various positions in the administrative hierarchy, for specific astronomical events and calculations. This level of terminological sophistication requires time to develop, requires communities of specialists who need precise language to discuss their work, requires institutional stability where knowledge accumulates across generations. Consider the Sumerian word me, one of the most enigmatic concepts in their language. The term appears frequently in religious and literary texts, usually translated as divine powers or cosmic ordinances. But those translations don't capture its technical specificity. The me weren't abstract principles. They were specific bodies of knowledge and technology, the art of metalworking, the knowledge of writing, the techniques of kingship, the secrets of sexual union, the methods of warfare. Ancient texts describe them as physical objects that could be stolen, gifted, or lost. The goddess Inanna famously tricks the god Enki into giving her over 100 me while he's drunk, and she transports them to her city. These aren't myths about abstract concepts. These are stories about knowledge transfer, about technology and expertise being moved from one center to another. The linguistic structure of Sumerian itself is peculiar. It's an agglutinative language, meaning it forms words by stringing together morphemes, small units of meaning in long chains. A single Sumerian word can incorporate subject, object, verb, and multiple modifiers, creating what functions as an entire sentence in English. This structure makes Sumerian incredibly compact and efficient for record-keeping, which is precisely what an administrative civilization would need. But agglutinative languages don't develop spontaneously. They represent a specific solution to linguistic needs, a design that prioritizes certain types of expression over others. The structure of Sumerian suggests it was shaped, perhaps over long periods, by people who needed efficient written communication for bureaucratic purposes. Even more intriguing is Sumerian's vocabulary for concepts that supposedly didn't exist yet. The language has technical terms for astronomical calculation that presuppose sophisticated observation and mathematical modeling. There are words that distinguish between different types of mathematical operations, specific vocabulary for geometric concepts, terms for measuring and dividing time according to complex calendrical systems. This isn't vocabulary that develops casually. This is technical jargon, the kind that emerges in communities of specialists who need precise language to communicate nuanced ideas. Where did this specialized vocabulary come from if Sumerian civilization was supposedly inventing these concepts for the first time? The Sumerian word sar, which we encountered earlier as a unit meaning 3,600, appears in multiple contexts with layered meanings. It's a number, but it's also a word meaning totality or universe. It's used in astronomical contexts to describe major cycles, in administrative contexts as a large counting unit, and in religious texts as a cosmic principle. This semantic density, where a single term carries mathematical, astronomical, and philosophical meaning simultaneously, suggests the word originated in a context where these disciplines weren't separate, where calculation and cosmology were aspects of a unified understanding. That kind of integrated knowledge system doesn't appear overnight. It's built over centuries in cultures where mathematics and metaphysics inform each other. And then there's the question of why Sumerian writing appears so suddenly. The earliest written records we have are already using the full cuneiform system, with hundreds of signs representing syllables, words, and concepts. There's no extended period of pictographic simplicity followed by gradual abstraction. Cuneiform emerges essentially complete, as if the scribes who developed it already knew what they needed the system to do. They weren't experimenting with how to represent language in visual form. They were implementing a solution, creating a writing system that could handle the complexity of their language and the demands of their bureaucracy. This suggests either that writing developed much earlier in a form that didn't survive, or that the Sumerians inherited the concept of writing from a predecessor culture and adapted it to their language. The linguistic evidence points toward inheritance rather than innovation. Sumerian contains loan words from an unknown substrate language, terms that don't follow Sumerian phonological patterns, and can't be analyzed using Sumerian grammar. These substrate words often refer to fundamental concepts: river, farmer, metalworker, date palm. They're not recent borrowings from neighboring languages. They're embedded in the core vocabulary, suggesting they predate the Sumerian presence in Mesopotamia. Some linguists have proposed that Sumerian was imposed on an earlier population whose language contributed these substrate terms. But if that's true, where did Sumerian itself come from? What population spoke it before arriving in Mesopotamia? And why does it have no linguistic relatives anywhere else? One possibility that orthodox linguistics refuses to seriously consider. Sumerian is an isolate because its relatives are all extinct, lost to the catastrophes that ended the antediluvian world. If there was a widespread civilization before the flood, and if that civilization spoke related languages, then Sumerian could be the sole survivor of an entire language family. The flood myths describe a world that was linguistically and culturally unified before the catastrophe. The Sumerian texts themselves speak of knowledge coming from antediluvian sources, of the me being gifts from gods who preceded human civilization. What if gods is mistranslation for ancestors? And what if the ancestors spoke languages related to Sumerian that didn't survive the transition? This interpretation gains support from Sumerian mythology itself. The Eridu Genesis, one of the earliest flood narratives, describes a time before the catastrophe when humanity spoke a single language. The text is fragmentary, but the implication is clear. Linguistic diversity is a post-flood phenomenon. Before the waters rose, there was unity of speech. After the flood, languages diversified, populations scattered, and communication became fragmented. If this is historical memory compressed into myth, then Sumerian could represent the last remnant of the pre-flood linguistic unity, preserved by a population that survived the catastrophe and maintained enough coherence to transmit their language intact, while other survivor populations developed new languages or lost theirs entirely. The technical vocabulary in Sumerian for concepts that supposedly didn't exist yet makes more sense if we understand it as inherited rather than invented. They had words for complex astronomical calculations because those calculations were part of their inherited knowledge system. They had sophisticated mathematical terminology because they were copying mathematical techniques from antediluvian sources. They had architectural vocabulary because they were restoring and imitating structures that had been built before the flood. The language preserves the fingerprints of a more sophisticated culture, one that had already developed technical specialization and needed vocabulary to match. When modern linguists say Sumerian is an isolate, they mean they can't connect it to anything in the known linguistic record. But the known linguistic record is incomplete, severely limited by the survival of written texts and the loss of countless languages that were never written down or whose texts didn't survive. We're comparing Sumerian to languages from the historical period, after the catastrophe, after the loss of the Old World. We have no linguistic data from before the flood. We don't know what languages were spoken by the antediluvian civilizations. All we have is Sumerian standing alone, linguistically unprecedented, carrying technical vocabulary that suggests knowledge its speakers claimed they inherited but couldn't explain. The language of the gods wasn't divine, it was ancient. And what the Sumerians preserved in their strange, isolated language was the linguistic residue of a civilization that spoke, calculated, and recorded in ways sophisticated enough to require technical terminology that we're still trying to fully understand 4,000 years after the last native Sumerian speaker died. There's a pattern in the archaeological record that shouldn't exist, a reversal so stark it challenges everything we understand about technological progress. When you examine the earliest monumental architecture, the structures built at the dawn of civilization, you don't find crude first attempts or experimental designs that improve over generations. You find the opposite. You find precision, sophistication, and engineering mastery that subsequent generations struggle to replicate. The oldest monuments are often the most impressive, as if civilization peaked at its beginning and has been in gradual decline ever since. This isn't how technology is supposed to work. This is the signature of inheritance, not invention. Göbekli Tepe in modern Turkey stands as the most troubling example of this reversal. The site dates to approximately 11,600 years ago, placing it at the very end of the last ice age, in the period when conventional archaeology insists humanity was still composed of nomadic hunter-gatherers, without the organizational capacity or motivation for monumental construction. Yet Göbekli Tepe consists of massive stone pillars, some weighing over 20 tons, carved with intricate reliefs of animals, arranged in circular enclosures according to sophisticated geometric plans. The engineering required to quarry, transport, and erect these pillars would challenge modern construction crews. The artistic skill displayed in the carvings rivals anything produced in later civilizations. And the astronomical alignments encoded in the site's layout demonstrate observational astronomy of startling precision. But here's the reversal. Göbekli Tepe wasn't followed by increasingly sophisticated structures. It was followed by simpler ones. The next several thousand years of construction in the region shows steady decline in scale and sophistication. Later monuments are smaller, less precisely aligned, more crudely carved. It's as if the people who built Göbekli Tepe possessed knowledge and capabilities that their descendants lost. The site wasn't humanity's first stumbling attempt at monumental architecture. It was a peak, possibly even a restoration attempt, built by people who still remembered how to work stone on a massive scale before that knowledge was lost to catastrophe and social collapse. The same pattern appears in Egypt, though the chronology is compressed. The pyramids of the 4th dynasty, particularly the Great Pyramid of Khufu at Giza, represent the pinnacle of Egyptian architectural achievement. The precision is staggering. The base is level to within 2 centimeters across a footprint of over 5 hectares. The sides are aligned to the cardinal directions with an error of less than 4 minutes of arc. The internal chambers and passages maintain precise angles and dimensions over hundreds of meters of solid stone. The casing stones, now mostly removed, were fitted so precisely that a blade cannot be inserted between them. This isn't the work of a civilization learning monumental construction. This is the work of master builders implementing a refined technique. Yet the pyramids that came after show steady decline. The 5th and 6th dynasty pyramids are smaller, less precisely constructed, built with inferior materials and cruder techniques. By the Middle Kingdom, pyramid construction has become so degraded that the structures begin collapsing almost immediately after completion. The knowledge that allowed 4th dynasty engineers to calculate loads, distribute weight, and maintain structural integrity for millennia was being lost, generation by generation. If the Great Pyramid represented humanity's first attempt at such construction, we'd expect to see improvement in later efforts. Instead, we see decay, suggesting that Khufu's engineers were working from superior knowledge, possibly inherited from earlier sources, that their successors couldn't maintain. The interior of the Great Pyramid reinforces this impression. The Grand Gallery, ascending at a precise 26-degree angle, features a corbelled ceiling that distributes weight through carefully calculated stone placement. The King's Chamber contains massive granite beams weighing 70 tons each, transported from quarries 800 kilometers away and positioned with precision that modern engineers struggle to explain. The so-called relieving chambers above the King's Chamber form a sophisticated stress distribution system that has kept the ceiling intact for 4.5 millennia, despite the immense weight of stone above. This engineering wasn't experimental or improvised. It was deliberate, calculated, implementing principles that require understanding of force vectors, material stress, and structural dynamics. But the Egyptians themselves insisted they didn't invent this knowledge. The inventory. Stela and other texts describe the pyramids being built according to plans from the first time, the mythological epoch when gods walked the earth and knowledge was given to humanity. Temple inscriptions at Edfu explicitly state that Egyptian temples were built according to plans recorded in ancient books, architectural blueprints from an earlier age that survived in the House of Life. The Egyptians saw themselves as restorers, not innovators, rebuilding monuments that had once existed and were being reconstructed from preserved designs. This makes sense of another archaeological mystery: why so many ancient structures appear to be built atop or around earlier foundations. The Osirion at Abydos sits beneath the temple of Seti I, built with massive limestone blocks that show weathering patterns inconsistent with the supposed construction date. The blocks are larger and more precisely fitted than anything in Seti's temple above, suggesting they come from an earlier period. The same pattern appears at temples across Egypt. Later, cruder construction built directly onto foundations that are more massive and more precisely engineered. The standard explanation is that Egyptians were reusing materials from earlier buildings. But what if they were building around structures they found already ancient, monuments they couldn't explain but recognized as sacred? The reversal appears globally. Sacsayhuaman in Peru features limestone blocks weighing over 100 tons, fitted together with such precision that no mortar was needed. Some stones have over 12 corners, each surface precisely angled to mate with adjacent blocks in 3 dimensions. The engineering required to shape these stones, transport them, and position them with such accuracy would challenge modern construction technology. Yet this fortress was supposedly built by the Inca Empire in the 15th century of the Common Era. However, the Inca themselves said they didn't build it. They told Spanish conquistadors that the fortress was already ancient when their empire rose, built by giants or gods in a previous age. They were simply maintaining and restoring what they found. The same claim appears at Tiahuanaco in Bolivia, where massive stone structures feature precise mortise and tenon joints, perfectly straight cuts, and astronomical alignments. The local Aymara people told early Spanish chroniclers that these structures predated the Inca, that they were built by a white and bearded race of culture bringers who came before the flood. Whether the ethnic descriptions are accurate or mythologized, the core claim remains: these weren't our structures. We found them already ancient. We maintained them, but didn't build them. Even in Mesopotamia, the pattern holds. The earliest temples at Eridu show the most sophisticated design and execution. Later temples built on the same site become progressively simpler, suggesting knowledge loss rather than knowledge gain. The Sumerians described their temples as restorations of structures that had existed in the antediluvian period, buildings that had survived the flood in foundation form and were being rebuilt according to sacred plans. The ziggurat wasn't a Sumerian invention, but a Sumerian reconstruction of an earlier architectural tradition. This architectural reversal has profound implications. If the earliest monuments represent the peak of technological capability, then civilization didn't begin with simple structures that gradually became complex. It began with complexity that gradually simplified as knowledge was lost. The trajectory isn't innovation building toward sophistication. It's inheritance degrading through catastrophe and social collapse. The great monuments weren't humanity's first attempts at architecture. They were humanity's last attempts to preserve and replicate what had been built before, to maintain connections to predecessor civilizations through monumental reconstruction. And this explains why so many ancient structures seem over-engineered for their supposed purpose. The Great Pyramid contains far more stone and precision than necessary for a tomb. Göbekli Tepe involves far more labor than a nomadic population could provide for a ritual site. Sacsayhuaman requires engineering capabilities beyond what the Inca civilization possessed for a fortress that was never fully utilized in warfare. These structures make sense only if they're copies, replications of earlier monuments built to preserve the memory and techniques of predecessor civilizations. They're architectural seed banks, preserving in stone the knowledge that written records couldn't maintain. The earliest monuments aren't primitive because they weren't first attempts. They're sophisticated because they're reconstructions based on inherited plans, executed by populations who still remembered, even imperfectly, how their ancestors built. As memory faded and knowledge eroded through successive catastrophes and collapses, the ability to replicate these structures diminished. Later generations built cruder copies, simplified versions, until eventually they stopped building in stone altogether, and the knowledge of megalithic construction was lost completely, replaced by myths of giants and gods who built what mere humans could not. The architecture doesn't lie. The oldest structures show the greatest sophistication, and sophistication declines over time. This isn't the pattern of invention. This is the pattern of inheritance and loss, of civilizations trying desperately to maintain knowledge through physical reconstruction before memory fades entirely, before the techniques are forgotten and the monuments become incomprehensible artifacts from a vanished world that possessed capabilities we can observe but can no longer replicate. When writing fails, when libraries burn, when cities flood and archives dissolve into mud, knowledge survives only if someone remembers. Not casual memory, not the vague recollection of stories heard in childhood, but precise, ritualized memory maintained across generations by specialists trained from youth to be living repositories of information. These weren't storytellers entertaining audiences with creative variations. These were human archives, memory keepers who understood that their culture's survival depended on perfect transmission of specific knowledge, who spent decades memorizing thousands of lines of technical data encoded in narrative form because narrative was the only storage medium that could survive catastrophe. The Vedic tradition of ancient India provides the most striking example of institutional memory preservation. The Rig Veda, a collection of over 10,000 verses, was maintained through oral transmission for thousands of years before being written down. But this wasn't casual oral tradition where stories change with each telling. This was formalized, ritualized memorization using sophisticated mnemonic techniques that ensured word-perfect transmission across centuries. Brahmin priests trained for years to memorize not just the words but the precise pronunciation, the tonal patterns, even the breathing points. Multiple memorization methods were employed simultaneously. Some priests memorized the text forward, others backward, others in complex patterns that allowed cross-verification. Any error would be immediately detectable because the different memorization methods would no longer align. But why this obsessive precision? Because embedded in the Vedic hymns, beneath the religious mythology, are astronomical observations, mathematical formulas, and technical knowledge that the priests might not have fully understood, but knew they needed to preserve exactly. The texts contain descriptions of stellar positions that are accurate for dates thousands of years before the supposed composition of the Rig Veda. They include mathematical relationships encoded in poetic meter, where the syllable counts of verses represent significant astronomical numbers. They preserve knowledge of precessional movement, of planetary cycles, of calendar calculations that presuppose generations of sustained observation. The mythology was the container, but the data was the cargo. The same pattern appears in other cultures that suffered catastrophic disruption. The Aboriginal peoples of Australia have maintained oral traditions for over 60,000 years, making them the longest continuous cultural memory on Earth. Their Dreamtime stories, dismissed by early European settlers as primitive mythology, have recently been recognized as encoding sophisticated geographical and environmental knowledge. Stories describe coastlines and islands that were submerged by rising sea levels over 7,000 years ago. They preserve memory of megafauna extinctions, of catastrophic floods, of landscape changes that geology confirms, but that occurred thousands of years before written records. This knowledge survived because it was encoded in narrative form and maintained by specialists who understood their role as cultural memory keepers. The Polynesian navigators represent another class of memory keeper, preserving technical knowledge through oral tradition with precision that rival written records. They memorize star paths, current patterns, wave formations, and bird behaviors that allowed them to navigate thousands of kilometers of open ocean without instruments. This knowledge was transmitted through specialized training schools, where students spent years learning to read the ocean, to recognize hundreds of stars and their rising points, to interpret subtle changes in wave patterns that indicated distant land. The knowledge was too complex and too essential to leave to casual transmission. It required institutional support, dedicated specialists, and formalized training methods. But the memory keepers weren't just preserving practical navigation or agricultural calendars. They were maintaining knowledge of catastrophic events, cosmic cycles, and warnings about future disasters. The flood myths we've examined weren't just stories about a past disaster. They were disaster protocols, instructions for survival encoded in memorable narrative form. The specific details that appear across cultures, the warnings to watch for signs, the instructions about building vessels according to precise dimensions, the emphasis on preserving breeding pairs and seeds. These aren't mythological embellishments. These are technical specifications preserved by memory keepers who understood they were maintaining disaster response information for future catastrophes. The Hopi of North America maintain oral traditions describing multiple world destructions, each brought about by different mechanisms: fire, ice, flood. The narratives include specific warnings about recognizing the signs of impending catastrophe, instructions for identifying safe locations, and protocols for preserving knowledge through the transition. The stories aren't metaphorical or symbolic. They're instructional, maintained by religious societies whose members undergo years of training to ensure perfect transmission. The Hopi memory keepers see themselves not as storytellers, but as archivists, preserving knowledge from previous worlds so that future generations might recognize the patterns and survive the next reset. Even in literate civilizations, memory keepers served essential functions. The Egyptian priesthood maintained oral traditions alongside written records, recognizing that papyrus could burn and stone inscriptions could be destroyed, but memory, if properly maintained, was more durable. Priests underwent decades of training memorizing astronomical observations, mathematical tables, medical formulas, and architectural specifications. Much of this knowledge was considered too sacred or too dangerous to write down, but it needed to be preserved. The solution was the same as in pre-literate cultures. Create a class of specialists dedicated to perfect memorization, develop mnemonic systems that ensure accuracy, and establish institutional structures that guarantee transmission across generations. The mystery schools of the ancient world, institutions like the Pythagorean Brotherhood or the Eleusinian Mysteries, functioned as memory-keeping organizations. The knowledge they preserved was transmitted only orally, never written, and only to initiates who had proven their dedication and reliability. What were they preserving that required such secrecy and such careful transmission? The fragmentary evidence suggests mathematical knowledge, astronomical observations, and technical information that Orthodox culture had lost or forgotten. The Pythagoreans preserved mathematical and musical relationships that they claimed as inheritance from earlier civilizations. The Eleusinian Mysteries performed rituals that participants described as revealing the secrets of life and death. Knowledge that ancient writers insisted couldn't be written down, but had to be experienced and memorized. The Druids of Celtic Europe maintained similar traditions, spending 20 years in training to memorize the laws, histories, astronomical knowledge, and ritual procedures of their culture. They explicitly refused to write down their knowledge, not because they were illiterate, but because they understood that written knowledge could be seized, burned, or corrupted. Memory, distributed across hundreds of trained specialists, was more secure. Julius Caesar noted with frustration that the Druids possessed extensive knowledge of astronomy and natural philosophy, but wouldn't commit it to writing, making it impossible to capture or destroy their intellectual tradition through military conquest alone. What all these memory-keeping traditions share is the understanding that knowledge is fragile, that catastrophe is inevitable, and that survival depends on maintaining information through the worst disruptions civilization can experience. They aren't preserving stories for entertainment. They're maintaining technical data, astronomical observations, disaster protocols, and warnings encoded in forms that can survive when everything else fails. The narrative structure, the poetic meter, the ritualized performance aren't artistic choices. They're mnemonic devices, error-checking mechanisms that ensure the information survives intact, even when the institutions that originally produced it have collapsed. And here's the truly unsettling implication. If these cultures invested such resources in memory keeping, dedicating years of training to perfect oral transmission of specific information, what knowledge did they consider important enough to preserve this way? The flood narratives appear across every culture that maintained memory-keeping traditions. The descriptions of astronomical catastrophes, of celestial bodies behaving abnormally, of skies that changed configuration, these aren't random mythological inventions. These are observations preserved by people who witnessed events that Orthodox insists couldn't have happened, preserved because the memory keepers understood that the next generation needed to recognize the warning signs. The memory keepers are still among us. Indigenous cultures worldwide maintain their traditions, still preserve knowledge in oral form, still train specialists in perfect memorization and transmission. But the broader culture has abandoned this practice, trusting written records and digital storage while forgetting that both can fail catastrophically. We've lost the understanding that institutional memory, maintained by dedicated specialists using formalized methods, is more durable than any technology we've invented. We've forgotten that our ancestors encoded warnings, technical knowledge, and disaster protocols in myths and rituals, precisely because they knew those forms could survive what written records could not. When the next catastrophe comes, whether flood, fire, electromagnetic pulse, or social collapse, our digital archives will vanish instantly. Our written records will decay within centuries. But the memory keepers, if we've maintained them, if we've trained them, if we've given them something worth preserving and taught them how to preserve it, they'll carry knowledge through the darkness. They'll be the bridge between what we achieved and what the survivors might rebuild. They'll speak the warnings we should have heard in the stories our ancestors preserved, the patterns we were too sophisticated to recognize, the knowledge we were too modern to believe. The memory keepers remember because someone must, because forgetting is extinction, and because the clay remembers even when we choose not to. Stand at Giza and draw a line through the 3 pyramids. Extend that line across the globe and you'll pass through more ancient sites than coincidence can explain. Travel to Angkor Wat in Cambodia, to Nazca in Peru, to Easter Island in the Pacific, and you'll find they sit on geometric relationships to each other that suggest coordinated planning on a continental scale. These monuments aren't randomly placed. They're positioned according to a system, a global grid that encodes astronomical information and geographical knowledge that supposedly didn't exist when they were built. The ancient world wasn't a collection of isolated civilizations independently discovering architecture. It was a network of sites deliberately positioned to preserve coordinates, to mark locations of significance, to function as a planetary surveying system that could survive catastrophe. The 3 pyramids at Giza align with extraordinary precision to the constellation Orion's Belt, as it appeared around 10,500 years before the Common Era, the same period suggested by the Sphinx's water erosion. But this isn't just symbolic correspondence. The pyramids are positioned at exactly 29.979 degrees north latitude, encoding the speed of light in the first 6 digits when measured in meters per second. This can't be coincidence. The meter wasn't invented until the 18th century of the Common Era, defined initially as 1/10,000,000th of the distance from equator to pole. Yet the Great Pyramid's placement encodes this relationship with precision that suggests its builders understood both the Earth's dimensions and the constant speed of light. They were leaving coordinates, embedding mathematical relationships that would only be recognized by a civilization sophisticated enough to rediscover them. The same pattern appears globally. Angkor Wat sits at 13.41 degrees north latitude, encoding pi in the first 3 digits of its distance from the equator in arc minutes. The site's layout mirrors the constellation Draco as it appeared around 10,500 years before the Common Era, the same date encoded at Giza. Teotihuacan in Mexico is positioned to align with significant stellar risings and sets. Its Street of the Dead, oriented 15.5 degrees east of north, precisely the angle required to point toward the setting position of the Pleiades on the date the site supposedly began construction. But Teotihuacan's astronomical alignments reference celestial configurations from much earlier periods, suggesting the site was positioned according to inherited knowledge of stellar positions from before the catastrophe. Easter Island, one of the most isolated locations on Earth, features massive stone heads that face inland, away from the sea, positioned according to astronomical alignments that mark significant solar and stellar events. The island sits at 27.1 degrees south latitude, a position that places it in precise geometric relationship to Giza, Angkor Wat, and other ancient sites when you map them on a sphere. These aren't approximate relationships. These are precise mathematical coordinates that suggest the sites were positioned using sophisticated surveying techniques and global geographical knowledge. Someone mapped the planet, marked specific locations, and built monuments at those coordinates to preserve the information. Nazca in Peru presents perhaps the most overt example of this coordinate system. The lines and geoglyphs aren't just ground drawings for ritual purposes. They're geometric markers, precisely aligned to astronomical directions and positioned to encode geographical relationships. When you map the major Nazca lines, they form a network of radiating alignments that connect to significant geographical features and to other ancient sites across South America. The lines function as a map key, a reference system that reveals relationships between locations when you understand the geometric principles involved. The creators weren't drawing pictures for gods to see from the sky. They were embedding coordinates, creating a surveying reference that would survive even if all other knowledge was lost. The geometric relationships between these sites follow specific mathematical ratios. The distance from Giza to Nazca is a precise fraction of Earth's circumference. The angular relationships between Giza, Angkor Wat, and Easter Island form equilateral triangles when plotted on a sphere. The sites cluster along lines of latitude that encode significant mathematical constants. Pi, phi, the speed of light, the dimensions of Earth. This isn't random distribution shaped by favorable geography or resources. This is deliberate placement according to a system, a global grid that encodes information in the positions of monuments themselves. But why create such a system? Why invest enormous resources positioning monuments at specific coordinates across the globe? Because coordinates survive when everything else is lost. When catastrophe destroys cities, floods valleys, and buries civilizations under sediment, the monuments remain, massive enough to withstand millennia of erosion. Their positions, their relationships to each other, their astronomical alignments continue to encode information even when no one remembers what information they're preserving. The global grid of ancient sites functions as a backup system, a way to preserve geographical and astronomical knowledge in the most durable form possible. Massive stone positioned according to mathematical relationships. The sophistication required to create this system is staggering. You need accurate maps of the entire planet to position sites in precise geometric relationship to each other. You need understanding of Earth's dimensions to encode latitudes that reference its circumference and polar flattening. You need astronomical knowledge spanning thousands of years to align monuments with stellar positions from different epochs. You need mathematical understanding to embed constants like pi and phi in the coordinate system. And you need global coordination, either a single civilization with planetary reach or a network of cultures working from a common plan, to position monuments on different continents according to the same geometric principles. Orthodox archaeology insists this level of coordination is impossible, that ancient cultures were isolated, that they had neither the geographical knowledge nor the communication networks necessary for global planning. But the monuments themselves contradict this insistence. The mathematical relationships are too precise to be coincidental. The astronomical alignments reference the same epochs across different continents. The geometric patterns are coherent and systematic, not random products of independent cultural development. The evidence demands either that ancient civilizations possessed capabilities we've denied them, or that they inherited this coordinate system from a predecessor civilization that mapped the planet before the catastrophe. The latter explanation fits the pattern we've seen throughout. sophisticated knowledge appearing fully formed, cultures claiming to inherit rather than invent their achievements, astronomical references to periods thousands of years before the civilizations that recorded them. The global grid of ancient sites represents inherited knowledge, a planetary surveying system created before the flood and preserved through monument construction by survivor populations, who maintained enough technical knowledge to position their temples and pyramids according to the inherited coordinates, even if they no longer fully understood why those specific locations mattered. Consider what this implies about the antediluvian civilization. They didn't just build cities and develop writing. They surveyed the entire planet, created a coordinate system encoding mathematical and astronomical information, and positioned marker monuments at key locations worldwide. This requires not just technical capability, but motivational sophistication. Why map the Earth so precisely unless you're planning for planetary scale events? Why encode information in monument positions unless you expect other knowledge systems to fail? Why create a backup that survives catastrophic destruction unless you've experienced catastrophic destruction before? The coordinate system suggests the antediluvian civilization knew they were vulnerable, knew catastrophe was possible, perhaps inevitable. They were creating a knowledge preservation system designed to survive the worst conceivable disasters. Written records could burn, spoken knowledge could be forgotten, but massive stone monuments positioned at precise coordinates would survive, would continue to encode information, would eventually be recognized by successor civilizations sophisticated enough to rediscover the mathematics and astronomy embedded in their placement. The global grid was a message to the future, a way to transmit knowledge across the catastrophe boundary where no other transmission method would survive. And we're only beginning to decode that message. As our surveying becomes more precise, as our astronomical calculations improve, as our understanding of Earth's dimensions becomes more refined, we recognize more relationships embedded in ancient site positions. Each discovery reveals another layer of sophistication, another mathematical constant encoded, another astronomical reference preserved. The monuments are talking to us, transmitting information across 10,000 years of silence, speaking in the only language that survives catastrophe: geometry, mathematics, and the unchanging positions of stones placed according to a plan we're still learning to read. The coordinates of forgotten cities aren't forgotten. They're preserved in the positions of monuments that still stand, waiting for civilizations sophisticated enough to recognize what they're looking at. The ancient world marked the planet with reference points, created a map that survives without paper or digital storage, encoded knowledge in the most permanent medium available. When you stand at Giza, at Angkor Wat, at Nazca, you're standing at a coordinate in a system designed to outlast empires, to preserve information through catastrophes that erase everything else. You're standing on a message from a civilization that knew it would fall, that planned for its knowledge to survive, in the only form that time cannot erase. Stone placed with purpose, aligned with intention, positioned according to mathematics that encode the warnings, the achievements, and the coordinates of a world that vanished but refused to be completely forgotten. Silence isn't absence. It's what remains when everything that could be destroyed has been destroyed, when the voices stop, when the last light goes out, when water recedes and reveals what it couldn't wash away. The silence in ancient sites isn't empty. It's dense with information, thick with the weight of everything that was lost and the fragments that somehow survived. When you stand in the ruins of Uruk, walk through the corridors of the Great Pyramid, or trace your fingers across cuneiform tablets in museum archives, you're not experiencing absence. You're experiencing compression, the distillation of entire civilizations into the smallest possible remnants, knowledge condensed until only the most essential information remains. We've traced that silence backward through 10,000 years of erasure and reconstruction. We've seen how flood myths aren't mythology but stratigraphic record, how impossibly long rains encode astronomical time rather than human chronology, how mathematical sophistication appears fully formed with no developmental precursor. We've examined erosion patterns that demand climates that shouldn't exist, libraries that reference texts we can no longer read, languages that have no linguistic relatives, and architecture that peaks at the beginning rather than progressing toward sophistication. Every piece of evidence points toward the same conclusion. What we call the first civilizations weren't first. They were second attempts, reconstructions built by survivors who inherited fragments of knowledge from a world that ended in catastrophe. The pattern is too consistent to dismiss, too global to explain through coincidence or cultural diffusion. Sophisticated knowledge appearing simultaneously across disconnected regions, all claiming inheritance from antediluvian sources, all describing the same catastrophic transition, all preserving the same astronomical references to periods thousands of years before their supposed emergence. This isn't independent invention converging on similar solutions. This is coordinated preservation, multiple survivor populations maintaining fragments of a shared knowledge system, each group preserving what they could from the wreckage of a predecessor civilization that had mapped the planet, calculated the stars, and built monuments designed to outlast catastrophe. But accepting this interpretation requires confronting an uncomfortable truth. If civilization has collapsed before, completely enough to erase nearly all record of its existence, then our own civilization is equally vulnerable. The knowledge we consider secure, stored in libraries and servers and institutions, could vanish as completely as the antediluvian archives. The technologies we consider permanent, embedded in infrastructure we assume will last generations, could be lost so thoroughly that our descendants debate whether we ever existed. We mock ancient claims of lost golden ages while ignoring that we're building our own golden age on foundations just as fragile as those that failed before. Consider what it would take to erase our civilization from the historical record. A catastrophic solar event, electromagnetic pulse that destroys all electronic storage and communication. Our digital archives gone instantly. A series of supervolcanic eruptions, ash-covering cities, populations fleeing, infrastructure collapsing. Our written records decay within decades without climate control. Rising sea levels from rapid ice sheet collapse, coastal cities submerged, populations displaced, governments failing. Our institutional knowledge disperses as specialists die without passing on training. It wouldn't take much, relatively speaking. A few catastrophes within a generation, overlapping faster than recovery can organize, and we're reduced to survival mode. Everything beyond immediate need becomes luxury we can't afford. Knowledge that isn't immediately practical gets lost first. And that's assuming survivors even try to preserve it. The Sumerians explicitly described their knowledge as recovered from antediluvian sources, maintained through deliberate, archival practice. The Egyptians built institutions dedicated to preservation, professional scribes whose sole purpose was copying and maintaining texts. The memory keepers across cultures understood their role as essential to survival. But modern culture has no equivalent institution. We've externalized memory to devices, trusted preservation to systems we assume will continue functioning. We've created specialists so narrow they can't explain their own fields to non-specialists. We've compartmentalized knowledge until no individual or institution maintains comprehensive understanding of how our civilization actually functions. When catastrophe comes, and the geological and astronomical records suggest it's a matter of when rather than if, what knowledge will survive? Not the digital archives dependent on electricity and compatible hardware. Not the specialized journals meaningless without years of prior education to understand them. Not the institutional frameworks which collapse when the institutions themselves fail. What survives is what can be maintained without infrastructure, transmitted without technology, preserved by people who understand that their knowledge is more valuable than their comfort. What survives is what the memory keepers preserve, what gets encoded in stone, what information is considered important enough to embed in monuments that will outlast everything else. This is what the silence of ancient sites is telling us. The antediluvian civilization likely possessed knowledge and capabilities that exceeded their successor cultures. They had global coordination sophisticated enough to position monuments according to planetary coordinate systems. They had astronomical observations spanning timescales that require institutional continuity across millennia. They had mathematical understanding that their successors copied but couldn't fully explain. They had engineering capabilities that later cultures struggled to replicate. All of that sophistication, all of that accumulated knowledge, and what survived? Fragments, coordinates embedded in monument positions, mathematical tables on clay tablets, erosion patterns on stone, flood narratives maintained by memory keepers who no longer understood the technical details they were preserving. The silence preserves warnings. Every flood myth, every description of catastrophic destruction, every narrative of survivors rebuilding from fragments is a message from people who experienced civilizational collapse and wanted future generations to recognize the signs. The astronomical references in ancient texts aren't religious symbolism. They're disaster indicators, descriptions of celestial configurations or events that preceded catastrophe, preserved so that future civilizations might have warning. The elaborate preservation systems, the memory keepers, the monuments positioned according to mathematical coordinates, all of this represents desperate attempts to transmit knowledge across the catastrophe boundary, to ensure that some information survives even when everything else fails. And we're ignoring those warnings. We've categorized them as mythology, dismissed them as primitive misunderstanding, relegated them to religious studies rather than treating them as historical testimony. We've chosen to believe that civilization is linear progress, that we're building toward ever-increasing sophistication rather than participating in cycles of rise and fall that have repeated before and will repeat again. We've convinced ourselves that our technology makes us immune to the catastrophes that destroyed predecessor civilizations. Even as climate change accelerates, asteroid detection remains inadequate, solar activity increases, and our dependence on fragile technological infrastructure deepens. The silence asks a question we're not willing to answer. What are we preserving? What knowledge are we encoding in forms that will survive our own collapse? We're not positioning monuments according to mathematical coordinates that encode essential constants. We're not training memory keepers to maintain technical information through oral tradition. We're not carving warnings into stone or embedding astronomical data in architecture. We're trusting digital storage that degrades within decades, depending on economic systems that could fail, assuming institutional continuity that history suggests is temporary. We're creating a civilization that will leave almost no recoverable trace if catastrophe hits within the next century. Future archaeologists, if they exist, if they develop the sophistication to investigate our ruins, will find the same pattern we've found in ancient sites. They'll excavate our cities and wonder why the oldest structures, the ones we're building now with advanced materials and engineering, are more sophisticated than whatever crude shelters were built immediately after our collapse. They'll find fragments of technology they can't replicate, references to knowledge systems they can't reconstruct. They'll debate whether our astronomical and mathematical achievements were really ours, or whether we inherited them from predecessors. They'll dismiss our warnings about climate change and technological vulnerability as mythology. They'll make the same mistakes we're making, refusing to believe that civilization before them also thought itself permanent, also assumed its knowledge was secure, also failed to adequately preserve what mattered most. The silence preserves one final lesson. Knowledge isn't naturally cumulative. It doesn't automatically accumulate and persist. It requires active, deliberate preservation by people who understand that catastrophe is possible and plan accordingly. The Sumerians knew this. The Egyptians knew this. The memory keepers across every culture knew this. They built redundancy into their knowledge systems, encoded information in multiple forms, created preservation methods designed to survive worst-case scenarios. And still, most of their knowledge was lost. Still, we're excavating fragments and trying to reconstruct comprehensive understanding from incomplete evidence. We have one advantage they didn't. We can study what happened to them. We can see the pattern of collapse and reconstruction, recognize the strategies that preserved some knowledge while most was lost, understand what forms of information storage survive catastrophe, and what forms fail immediately. We can learn from their desperation, their preservation attempts, their failures and partial successes. We can choose to be the first civilization that breaks the cycle, that preserves enough knowledge through catastrophe that the next iteration doesn't have to start from fragments. But that requires acknowledging the cycle exists, accepting that we're vulnerable, and investing resources in preservation methods we hope never to need. The monuments stand in silence not because they have nothing to say, but because we've forgotten how to listen. The coordinates are still there, encoded in positions that won't change. The mathematical constants are still embedded in ancient architecture. The astronomical references are still accurate for the epochs they describe. The flood narrative still preserves disaster protocols and warnings. All of it is talking, has been talking for thousands of years, waiting for a civilization sophisticated enough to decode the message and humble enough to heed the warning. We're that civilization now. The question is whether we'll listen before the silence claims us too, before our own achievements become mysterious fragments that future archaeologists dismiss as mythology, before the cycle completes and everything we've built becomes evidence in arguments we'll never witness about whether we really existed at all.
If you enjoyed the video, hit the like button, subscribe, and activate notifications so you don't miss our next videos.